Hello everyone, my name is Mark Fennell, and today I'm going to talk to you about the Austin water supply system and my proposal for improving the filtration of the Austin water supply system. So here's what's happened in the last couple of weeks. There's been a heavy amount of rain, not flood rain, not excessive rain, but rain. I wouldn't even say it's more than average. I mean, it's not really been that much. To me, it hasn't been that much heavy rain. It's been rain, but not extreme. But the Austin water supply, the Austin is a filtration system, and apparently their filtration cannot filter the water now. And it's to the point where everybody who's part of the Austin water system must boil their water. They must get, sealed water from out of town, right? So they must get packaged water from out of town. They must boil that water. That's for the entire city area that's been affected. Now, you'd think that this was some sort of major flood. No. Some hurricane. No. It really hasn't been that much of excessive rain, which means that if the water filtration, the filtration system can't handle this, then obviously it's been designed wrong. There needs to be better design in the system. Okay? So that's what I'm going to talk about today. Obviously, it's a design flaw, not an extreme weather event, but a design flaw. So basically, as I understand what has happened is, what happens when things rain is that the sediment will also come through the system, and that sediment always, brings up the level of the reservoir, and it'll keep flowing the rivers, and obviously there's more and more erosion because of the rain coming through. There's more and more sediment coming through, and by the time something comes all the way down to the end of a path, you're going to get a lot of sediment down there. Okay? Now this is typical. This is what happens in the Mississippi River, for example. The Mississippi River becomes close to mud towards the end because of all that sediment that comes through. All right, so that's normal. The Aswan Dam, all right, in ancient Egypt, the Nile would get all the sediment down through the delta. It actually was good for the nutrients, because that's how come the Nile Valley was so fertile, was because the nutrients far back came through. Now that the Aswan Dam is there, the sediment, it becomes built up on the Aswan Dam, and the Nile is actually less fertile than it was before that time, right? Because the dam has blocked it. So this is common. This is what happens. This is how nature works. But apparently Austin has not figured out a way to take out the sediment before turning into drinking water. Okay? The design flaw. Now I'm familiar with the Austin water system, and basically what happens is there's a series of lakes. I think there are 5 lakes. So it goes lake to lake to lake to lake to lake, and each one there's a dam. Like there's a reservoir and a dam and a waterfall, and a reservoir and a dam and a waterfall, reservoir, dam, waterfall, kind of all the way down. And the floodgates are open as needed or closed as needed, and it comes all the way through. Okay? That's to handle the water supply when there's a rain going on. So it's not like the whole territory is going to be flooded at once. It's kind of handled. Right? But by the time it comes down to Austin, if you don't do anything with it, you're basically getting mud. Okay? you would think they would have built enough filtering systems either at that point or along the way to do filtering. Well, they haven't. So here's the basic solution. The basic solution is to filter along the way, right? You're going to divert some of the water off of each of the reservoir, and that's going to be your drinking water. That canal will lead you to a filtering system, filter some of that water, go into the drinking water supply. Okay? If you do that at each one of the reservoirs, then you don't have to collect all the mud down at the bottom and try to filter everything off at once. Also note that only a small portion of the water is being diverted to the filtering system. The rest of the water with all its sediment is continuing to flow down the regular lakes and river and on down. Okay, so if we do this, then we're filtering a little bit at a time. We're also filtering it where there's less sediment because it hasn't accumulated. Okay? I'm going to draw you a simple little sketch. Very simple. Okay? Okay. So this is essentially what the Austin system looks like. You've got a reservoir, and then the river, and a reservoir, and a river, and a reservoir, and a river, and a reservoir. I believe there are 5 of them. And at each of these points just before the river, this is where the dam is. That's where the dam makes the edge of the reservoir, obviously. And then there's got the floodgates, and some of these provide electrical power, hydropower as well. Okay? So that's the basic system as it is. And the sediment will accumulate from each one of the reservoirs, each one of the rivers, all the way down the line. Okay, now let's do this. Okay, so instead what we're going to do is we're going to add a filter system and leading to the drinking water supply at each one of the reservoirs. So a small channel will divide a small channel which will divert some of the water, a mile or so, to a large filtering plant. Okay, the filtering plant will then clean up the water, make it useful for drinking water, and then give it to the local water supply. Okay, at that point, that's the same Austin Regional Water Supply. We just got a new filtering system and a new entrance point for clean water. Okay, so we do this the first reservoir. That means there's going to be less sediment at that point because we haven't built it up. And this continually goes through. The water comes through into the system, water comes through to the system, water comes through to the system, and there it is. Okay, we do the second one as well. So there's also the second one as well. Okay, we can go down to the third one as well. So let's say we've got 3 of these filtering systems, each just a mile away from the reservoirs. And while the water, the rain is continually coming down, and the floodgates are doing their thing, there's also the side channels to their filters. So all the time that the rain's coming down and the reservoirs are filling up, we're also filtering the water at that same time at each one of those reservoirs. And then each filtered water is going then directly into the water supply. Okay. So that way we're doing it, first of all, we're not doing it at one location, we're doing it in multiple locations. Secondly, we're doing it earlier where there's less sediment. Okay. And we're doing it ongoing while the rain is coming down. Okay. If we design this system, then we won't have this muck at the bottom. We won't have to have Austin Water Supply doing all the filtering at the same time. Okay? And we won't have this problem of not having enough clean water for the people. Okay? So that's the basic system idea. Now there's another thing too where if there's a lot of sediment, we'll want to clean it out. Now this too is always the case. At least every year, the major rivers that have the sediment problem needs to be dredged out. That's just a way of life. And if you're not doing that, then you're just continuing out of the problem. So that's another thing that needs to happen at least once a year, more often if you need to. Dredge the reservoirs of the additional sediment and take it out. Okay? This is easily done with, just simple equipment is easy to do that with. Another thing is that some of the sediment is actually good with nutrients. So you want to take some of that out and keep it and use it for the agricultural land surrounding the area. Okay? So you want to do that as well. You may not want to do this while the thing's flowing through, but then again you might. Okay? And that leads me to the second proposal design. And that is where we insert filters into the reservoirs. Okay? We're not going to filter out everything, but we're going to filter out a good chunk. And these filters are going to be placed inside the reservoirs. They're going to be rectangle, and they're going to be set, basically sideways. So the river's going to come through this way. The rectangular filter is going to be here. It's going to collect a lot of the debris, a lot of the sediment. Okay? Sediment which is not good for drinking water, but sediment which is likely also good to have agricultural good nutrients. Okay? So we collect it to prevent it from getting to the drinking water. We also collect it so that we can remove this filter. We have some good vitamins and nutrients to give to the regional agricultural environment. Okay? That's how that's going to work. We'll just give a simple little sketch of how this is going to look. Okay? Okay, so we're going to have a rectangular filter system. Right? This thing is going to be large. It's going to be several feet by several feet. And I would recommend having multiples of these together. You can have them in a line. Right? All right, you can have multiples of these rectangular filter systems together in a line. Okay? This will all be underwater. Okay? This will all be under the water system, under the water level. Right? So now what's going to happen is, as the water comes through and brings its sediment, this is always going to happen, whether it's light rain or heavy rain, whatever else. Water comes down, it flows through, it pushes the other water through, it flows through, brings sediment from the dirt around it, blah, blah, blah. But when it comes to each of the reservoirs, now the water as it comes through the reservoir, and before it comes through the dam, you'll have each one of these block filters. Okay? The water flow through there, the debris will be collected. The sediment will be collected. I keep calling it debris, but there is debris, but it's also most of it sediment. It's the dirt and the nutrients, and these all be collected in the boxes. Okay? All right. Now, when each of these boxes is full, it's very simple. We just take a series of cranes, lift it out, move it over, bring it onto land. Now the filters can be collected. The debris that's in here, the sediment that's in here, can be collected. So first of all, it's less sediment that's been sent through the system, but also we're capturing nutrients, and these nutrients are good for the agriculture, right? And we don't have to take it far, because usually there's good agriculture in the surrounding territory. All right, so we just give it. We just give it to the local ranchers and local farmers. You know, just give it to them. Easy. Then once that's done, we put the filter back into the system underneath the water, and more will come through. Now, obviously, it's best to have multiple filters so you can do this in series. All right, so let's say there are 5 filter boxes across. When they're full, you take those out. You put another 5 filters in. Those are collecting. Meanwhile, these other 5 filters go through their removal process where you collect all the sediment nutrients. Those are shipped off and spread around the local agricultural supply. And by the time these are full, these get taken out. The now empty ones will get put back in. And you can do this complete cycle. So it's good to have at least 2 sets, maybe 3 per reservoir while we do this. Okay? Now these are going to be easy to put in and out because all we need is a crane. We just attach a crane system, right? We hook it to each of the 4 points in the box, lift it out, crane moves it over on the land, puts it down the ground, or puts it on a transportation truck or something. Okay? So, very easy, very easy. Okay. Now we're going to place these in the reservoirs. They can be anywhere in the reservoirs, it really doesn't matter, but it certainly needs to be before the dam, all right? Before the dam level. So let's take a top view. Okay, so this is top view. Let's say this is the dam right here with the hydropower, and then, you know, a few feet back, 100 feet back, 200 feet back, I don't know how many, 1,000 feet back, we'll put the filter boxes down in here. Right? Don't need to put it too close to the dam, but there's no need to that. We can put it anywhere. Anywhere. We can put it anywhere. Doesn't matter. Middle, close, up front. Doesn't matter. Okay? All right. Okay, so those are my basic ideas for fixing this problem. Right? Again, the first method is to have multiple filtration units on the side. Okay? Multiple filtration units on the side. At each reservoir, there's going to be a channel. It's going to lead to a separate filtration system, and then that'll be given to the local water supply. Okay? There's less sediment up here, less to filter. It'll be easier to do. It'll be continuous. Do these are the first couple reservoirs. Ongoing as the rain comes through, not a problem. Ongoing system, all the time. And then the second part is to have the internal filtration system, which are a series of boxes. These are going to be several feet by several feet in a rectangle. Filtering, which basically means it's going to collect the sediment, but let the water come through. Okay? Each one of these boxes can then be craned out. The sediment is collected and kept because it has nutrients. These will be given to the local agricultural environment, spread out as needed, good for the agriculture. All right? Then the clean, empty containers are put back in, right? And of course, the sediment being removed means it's blocked in here. There's going to be a lot that's not taken through the system. All right, so that's even less sediment coming through and less sediment that you have to filter in any clean water system. Okay, and of course, you don't have to have this. You don't need to have a pure reservoir filtration system. You can let a lot of sediment come through. I mean, you get a lot of sediment come through. That doesn't matter, but you'll be collecting a lot of it, so that a lot of it won't come through. Easier to filter in the drinking water filtration systems, and most of it will be used for the agricultural systems. Okay, this is designed for the Austin water system, Austin, Texas water system, but it can be used for anywhere in the world, really. Okay, so those are my ideas. Use them, build them, take advantage of them. Okay, there you go. Thanks for listening, and use clean water. Make it yours.